Hello. 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 Can you hear me?
Hello,
Yeah.
sir. Can you wait for a minute? I'll rejoin the meeting.
Okay.
Okay.
Hello. Can you hear me now? Hello. Hello. I can't hear you.
Hello, sir. Am I audible to you?
Yeah. Uh, you can hear me, right? Okay. So
Yes.
we'll begin with monotonic sequences. So first of all, the definition, a sequence Fn is said to be monotonically increasing if Fn plus 1 is greater than equal to f of n for all n belongs to natural numbers. Basically, every successive term is greater than equal to the previous term. That sequence, this type of a sequence is a monotonically increasing sequence. If Fn plus 1 is less than equal to f of n for all natural numbers, that is a monotonically decreasing sequence. Monotonically decreasing. So obviously there is possibility that some sequence could neither be monotonically increasing nor be decreasing, right? This condition has to be true for all terms and for all terms for it to be increasing or decreasing.
Right.
So now some theorems related to the monotonic sequences. The first one says every monotonically increasing sequence, monotonically increasing sequence which is bounded above, which is bounded above converges to its least upper bound. What does this mean? If it is a monotonically increasing sequence, basically terms are increasing, and suppose we know that the sequence is bounded above. Bounded above means there is a value, let's say b. No term of the sequence is going to be greater than b. Every term is less than equal to b. So b becomes an upper bound. So this theorem is saying that every monotonically increasing sequence which has an upper bound will always converge to its least upper bound. So what is the least upper bound? So if a sequence has an upper bound, let's say b, then obviously b plus 1 is an upper bound also, right? And b plus 2 is also an upper bound. There are infinite upper bounds, right?
Right.
If all the terms are less than b, then obviously it will be less than other upper bounds. There are an infinite number of numbers greater than b, which are also upper bounds. So a monotonically increasing sequence which is bounded from above will converge to the least upper bound. B is the least upper bound here.
Okay.
Because all the terms, there is no number less than b for which we can say that every term of the sequence will be less than b. And there is no number, I mean, after that, every other number you can say that, right?
Right.
Similarly, the other version of this is if it is a monotonically decreasing sequence, monotonically decreasing sequence, which is bounded from below, which is bounded from below, will converge to its greatest lower bound, will converge to greatest lower bound. This is just the opposite of this. Here we are saying that if the sequence is a monotonically decreasing sequence, every time it keeps decreasing terms, and there is a lower bound, it never goes below a certain value. Then if you have one lower bound, then obviously any number below that is also a lower bound.
Lower bound.
So there are infinite lower bounds, but one of them will be the greatest lower bound, and the sequence will converge to the greatest lower bound. Right?
Right.
Then the second one is this. A necessary and sufficient condition. A necessary and sufficient condition for a monotonic sequence to be convergent. If you have a monotonic sequence and you want to find out whether it converges or not, a necessary and sufficient condition for that is that this sequence is bounded. This is a consequence of the previous two statements, because we know that a monotonically increasing will converge to the least upper bound, and the monotonically decreasing sequence will converge to the greatest lower bound. Right? So basically, as long as you have a monotonic sequence that is bounded, that means it has upper bounds and lower bounds and all, it will be convergent. Right?
Right.
So the consequence of this is that every monotonically increasing sequence which is not bounded above, which is not bounded above, will obviously diverge to infinity. And same thing, every monotonically decreasing sequence which is not bounded from below will diverge to minus infinity, right?
So this is the conclusion of the theorem.
This is, from this only it is obvious.
Oh, yes.
If it is not bounded above and terms are increasing, it will go to infinity.
Yes, sir.
So, for example, prove that the sequence sequence is given by 2n minus 7 by 3n plus 2 is monotonic, bounded, and therefore converges. Find the limit.
That the sequence.
First, you have to prove that it is monotonic and bounded.
Mm. Sir, its least upper bound will be 2 by 3.
First, you have to prove that it is monotonic and bounded. How do you prove monotonic?
Sir, we will prove that it is convergent.
How will you prove that it is convergent?
Sir, we will take its we will limit n tends to infinity.
Taking the limit is not a proof that it is convergent. To prove that it is convergent, you have to show that it is monotonic and bounded.
Okay. Okay, sir, we will. This is what we have given. We have been given f of n.
Mm-hmm.
Now, like we will calculate f of n plus 1,
Mm-hmm.
and then we will like take the ratio of them.
Ratio.
F, yes, like f of n. We will like compare f of n plus 1 and f of n, and if like f of n upon f of n plus 1 upon f of n is greater than equal to 1, then we will say it is monotonically increasing, and if it is less than, then we will say it is monotonically decreasing.
You can say that by doing difference of f of n plus 1 minus f of n, right?
Right, like we did in the previous class with
Just now we have said that what is the definition of monotonic? Use the definition of monotonic sequence.
f of n plus 1 is greater than equal to f of n.
So see that whether it is true or not.
Yes. सर मतलब सेम चीज ही तो हुई f of n plus 1 upon f of n greater than 1 प्रूफ करना, वो भी तो सेम चीज ही हुई.
I'm asking you to use the definition so that you remember the definition.
Okay.
सेम चीज हुई मतलब पिछले क्लास का चीज ही करना है, इस क्लास में नहीं सीखते हैं कुछ भी. F of n plus 1 minus f of n you cannot find out.
No sir, I am मतलब निकाल रहा हूँ.
To see that whether it is greater than 0 or not. F of n plus 1 minus f of n is coming out to be what?
सर एक मिनट बस आ गया. सर 4n minus 4 upon 3n plus 2 3n plus 1.
4n minus 4. What is f of n plus 1?
f of n plus 1 is 2n minus 5 upon 3n plus 1.
3n plus 1.
Yes sir. नहीं तो गलत कर दिया. Yes sir.
It is
नहीं
3n
गलत.
plus 5.
हाँ वो प्लस अच्छा हाँ yes sir 3n plus 5.
Find the correct value for difference.
Twenty-five upon 3n plus 2. 25 upon 3n plus 2, 3n plus 5.
Is it going to be positive or negative always?
Or positive always.
That means it is monotonically increasing. How will you show that it is bounded? Bounded means it has upper bound and lower bound.
Yes sir, तो फिर उसके लिए तो लिमिट ही यूज करेंगे ना, मतलब लिमिट एंड टेंड्स टू इंफिनिटी.
No, that doesn't mean that you have to show that it is greater than something and lesser than something. उसके लिए लिमिट कैसे यूज करेंगे?
अच्छा तो एक मिनट मैनिपुलेट करेंगे कुछ ऊपर न्यूमरेटर को.
Find the value of 1, 2, 3, some first few terms. If you find first few terms, you'll get the idea it is greater than what and less than what.
Okay sir.
These are the first few terms.
Yes sir, पहले 2 तो आ.
It is clear from here that -1 could be your lower bound, right?
Right.
It's monotonically increasing and -1 is my lower bound. You can check that by doing -1. You trying to prove that Fn is always greater than -1. So find the value of 1 plus Fn. 1 plus Fn, it will come out is always positive. 1 plus Fn, if you do, it will be 5n plus 2 minus 7 by 3n plus 2, which is 5n minus 5 by 3n plus 2. Uh, 5 n minus 1 by 3n plus 2. And since n is greater than equal to 1,
5n, yes sir.
this is always positive. Similarly, you can try and guess what the upper limit will be. You can try and guess. It looks like it is becoming fractions. So maybe you can check Fn is probably less than 1. You can check that. Looks like it is fractions and the values are small only. So you can check Fn less than 1 or less than 2, whatever. You will get Fn minus 1 when you check, you will get again, it is positive, is like negative.
मतलब Fn जब हम डालेंगे कि equal to 1 हो तो n नेगेटिव आ जाएगा, यही कहना चाह रहे हैं ना?
We have to show that it is less than some number. So fn minus 1, fn should be less than equal to 1 or 2 or whatever number you decide.
Okay, but like if I'm doing for like 1, then n will be negative. So
How
obviously,
will n be negative?
so that is not possible.
N is negative in this sequence. How is n going to be negative? This sequence is defined for natural number, no? 1, 2, 3. क्या बोल रहे हो? n नेगेटिव कैसे है?
Hello.
Hello?
Yes, sir.
How is n coming negative? You have to show that for all natural numbers, fn is less than 1.
Yes, सर लेस देन 1 के लिए ठीक है, लेकिन इक्वल टू 1 के लिए करेंगे तो फिर नेगेटिव आएगा, तो वो मतलब 1 तक कभी पहुंचेगा नहीं ना. अगर हम इक्वल टू 1 के लिए करें तो
Is it convincing you that it is less than 1 then?
yes sir.
If you have proved that it is less than 1, then what is the problem? It is bounded then.
Yes sir.
Prove that the sequence is convergent, and this is true for the limit. You have to prove that it is monotonic and bounded. If you can prove that it is monotonic and bounded, then it
तो
is
कन्वर्जेंट हो जाएगा. सर मोनोटॉनिक तो हो गया.
कैसे हो?
f of n plus 1 minus f of n किया तो 1 upon n plus 1 factorial आ रहा है.
So it is monotonically increasing or decreasing?
मोनोटोनिकली इंक्रीजिंग है या डिक्रीजिंग है, ठीक है। एक वो सर हमेशा पॉजिटिव होगा, तो मतलब इंक्रीजिंग है मोनोटोनिकली।
Find the bounds then.
सर लोअर बाउंड तो 1 होगा।
लोअर बाउंड 1 होगा तो ये कैसे प्रूव करोगे? 2? I think there is a missing 1 here. It should be 1 plus. You can put a 1 plus here.
ओके सर, तो मतलब ऊपर वाला पहली चीज तो सेम ही रहेगी फिर भी मोनोटोनिक बनना हो तो।
If you put a 1 plus, then lower bound is 2 is obvious.
हाँ, वो 1 की जगह 2 हो जाएगा, +1 ऐड हो जाएगा।
How will you get the upper bound?
ठीक है सर, ये ट्राई करता हूँ। सर वो जैसे 1/1 × 2 है, तो उसको मतलब 1 को 2 - 1 लिख सकते हैं थर्ड टर्म में। सेकंड टर्म में जैसे 2 - 1, थर्ड टर्म में 2 - 1 लिख सकते हैं। फिर थर्ड टर्म में ऊपर जो न्यूमरेटर उसको 3 - 2 लिख सकते हैं।
That will not help much because what will happen? 3 minus 2, so it will become 1/1 plus 1/1 2 minus 1 by 1 into 3.
वो previous
Won't cancel. After that, it will be difficult to keep doing it. You can say that an will be less than 1 by 1 by 1 plus 1 by 2 into 2 plus 1 by 2 into 2 into 2. This will be true. These are smaller number. An will be greater than, I think you can say, right? It will be greater than, you can say.
exactly. Greater होगा
This is a GP. It starts from here. Actually, okay. Instead of saying greater, we can say less than if we change it a little bit. We don't change anything in third term. We start from the fourth term. We say an is less than 1 plus 1 by 1 plus 1 by 1 into 2 plus 1 by 2 into 2. Right? Plus 1 by 2 into 2 into 2. Here it would have been 1 by 1, 2, 3, 4. Right?
right.
So now it is a less than thing. Right?
Right.
Here it will be 2 power n minus 1 because fourth term we have 2 cube. So nth term will have 2 power n minus 1. Right? So this is a simple GP whose sum you can find. An is less than 1 plus. What is the sum of this GP?
That is 1 into 1 minus r to the power n.
So what is that?
R is half. Upon 1 minus r.
An is less than 2, 1 minus half power n plus 1. This is 3 minus 2 into 1 by 2 power n. Right? An is just less than 3. So you'll get this upper bound. Correct?
Correct.
You're getting the upper bound or saying that we can change it slightly and make a new sequence. And make a new sequence such that the new sequence is bigger than the old sequence. So you can say an is less than at least this new sequence. New sequence is easy to sum because it's simple GP. So you can prove like that that an is less than this. So if the terms are less than this, then obviously there is now an upper bound and a lower bound, and it is monotonically increasing. So it will converge to the lowest upper bound. When you do n tends to infinity, this part tends to 0, it converges to 3. Right?
Right, sir. सर एक चीज पूछनी थी, जैसे एसएस में ये भी तो लिख सकते थे an, मतलब इसमें ऐसे क्यों लिखा है लिमिट n टेंड्स टू इंफिनिटी an?
It's converging to something less than 3.
तो ठीक है, और फिर ये ग्रेटर देन इक्वल टू 2?
That we have already seen, no?
नो,
You have already seen that it is first two terms are only greater than 2. What is the first two terms of this sequence? Hello? Hello?
हेलो,
First two terms of the sequence were already greater than 2, right?
राइट सर।
So obviously it is greater than 2, the whole an.
सर उसमें प्रॉब्लम नहीं थी, वो तो पता था सर, वो बोला था मैं नोटेशन में, शायद इंटरनेट कनेक्शन सही नहीं होगा मेरा, तो फिर वो डिस्कनेक्ट हो गया था, तो सुन नहीं पाए होंगे आप मुझे।
Notation is just saying what is the limit of n tends to infinity, and that is the limit of the sequence. Is it greater than 2 or less than 3? Is your
ओके ओके सर, ठीक है, समझ में आ गया। पर वैसे तो हम जो लोअर और अपर बाउंड है वो ऐसे करते थे ना, जो नॉर्मल ए एन का जो सीक्वेंस का हमारा नोटेशन होता है वो डाल के, इट इज फ्रॉम 2 to 3।
Yeah, but in the question is asking about the limit. So we'll start the topic of subsequences. Subsequences basically is a slightly special topic for, and it is there in your syllabus. It has been asked, right?
राइट सर।
So definition is this: let Fn be a given sequence if Nk is a strictly increasing sequence of natural numbers such that basically n1 is less than n2 is less than n3, then f of nk is a subsequence of f of n. So what is he saying? Fn is some sequence, some given sequence. Obviously, Fn means what terms? F1, F2, F3, F4, and so on. Fn plus 1. This is the normal sequence, right? Now, Nk is a new sequence and it's a strictly increasing sequence of natural numbers. So that always Nk means that maybe Nk stands for 1, 4, 7, 8, 9, 13, whatever. This could be your Nk as long as it is strictly increasing, right?
राइट।
So as long as it is a strictly increasing sequence of natural numbers, you can now find this sequence, which is basically F1, F4, F7, F8, and so on. And that will clearly be a subsequence of this original sequence, because this thing is a subset of the n set, right? Basically, you are just selecting some portions of the original sequence. You're saying this one, F4, F7, F8, and so on.
और वो ग्रेटर देन में अपने आप ही ऐसे सेलेक्ट कर रहे हैं कि जो ग्रेटर है कंसेक्यूटिव
Consecutive नहीं.
हाँ मतलब वैसे ग्रेटर है ना मतलब n1 मतलब n2 n1 से बड़ा है.
This is the definition. You have to take a strictly increasing sequence that is part of sequence of natural numbers basically, and any strictly increasing sequence of natural numbers, if you put as a subscript of f of n, then that becomes a subsequence of your original f of n. For example, 1, 3, 5, 2n minus 1, so on. 2, 4, 6, 2n, so on. These are, and let's say one more, 1, 4, 9, 16, so on. These are all subsequences of n. The sequence n has all natural numbers. Here we are selecting some subset of them, right? Here also some subset of them. Here also some subset of them. As long as they are strictly increasing. Right?
Right.
So what was nk here? Here nk was what? Nk was 2n minus 1. 2n minus 1 is a strictly increasing sequence of numbers. Right?
Right.
So those numbers only, if you select out of all natural numbers, you will get this subsequence. Nk here was 2n.
2n.
Nk here was
n
n
square.
These are all strictly increasing sequences of natural numbers. Right?
Right.
Similarly, 2, 3, 5, 7, 11, so on. This is a subsequence. This is also a subsequence. It is a subsequence of primes, basically. But it is a subsequence of, you can say, n. Right?
Right.
However, this time you will not be able to find the nk rule. We don't know the rule by which you are getting this.
Prime का नहीं है अभी तक हमारे पास.
Because nobody knows that rule, but still it is a subsequence of the natural numbers.
Right.
So basic idea of subsequence is an increasing subset out of a original sequence that can be called a subsequence. Now, first theorem here is if a sequence Fn converges to L, then every subsequence of Fn converges to L. That is very important. If a sequence you can prove is convergent, then any possible subsequence of that will also converge to the same limit. Okay?
Okay.
This is clear, right?
Right.
Then from there, you can say number 2 is all subsequences of a convergent sequence converge to the same limit, right? This is saying the same thing in theorem 1. It's just saying that if it is a convergent sequence, it has some limit, then all the different subsequences will also have the same limit, right?
Right.
Now, converse of theorem 1 is not true. Theorem 1 is not true. What does that mean? It means that if the subsequences are convergent, right, then doesn't mean that the sequence is convergent, right? So for example, let's say our sequence was -1 power n, right? So the sequence will have terms like -1 plus 1 -1 plus 1, right?
It will diverge.
This sequence clearly has no limit, it doesn't converge. However, there is a subsequence here inside it, which is just 1 1 1 1.
That converges.
So subsequence is converging to 1, but that doesn't mean that overall sequence will converge to 1.
Right. Right.
Converse is not true. Subsequence does not imply sequence will converge. The opposite is true. Sequence, if it converges, then subsequence will converge. Right?
Right.
One more thing to note here is if you want to prove that a sequence is not convergent, right, then it is sufficient to show that two different subsequences of the original sequence converge to two different limits. You understand?
Yes, sir.
If I have one subsequence, let's say f n k, and another subsequence g n k,
So
and this is
previous one
going to
example.
L1 and this is going to L2, that means that sequence Fn is diverging. Why? Because we saw that if the sequence converges, then both subsequences should have the same limit.
Right.
Right?
वो -1 to the power n का एग्जांपल ले सकते हैं.
Yeah. Basically, if it has to converge, then all subsequences will have same limit. Right? Makes sense, right?
Right.
Then the next theorem is if the subsequences f2n minus 1 and f2n of a sequence fn converge to the same limit L, converge to the same limit L, then Fn also converges to L. Also converges to L. So basically, it's saying that if the odd term subsequence and the even term subsequence, right, both are having the same limit L, then the overall sequence also has the same limit L. Right? This subsequence would have been consisting of terms f1, f3, f5 and all. and this one consists of f2, f4, f6 and all. If both are giving same convergent limit L, then the overall sequence is also convergent, right?
Right.
The next one is if a sequence Fn, if a sequence Fn diverges to infinity, then every subsequence also diverges to infinity. Every subsequence of Fn also diverges to infinity. So similarly, you can say the same thing. If it diverges to minus infinity, then every subsequence also diverges to minus infinity, right? Uh, this is important because you realize that sequences can be divergent in multiple ways. There could be divergence because there was no common limit, right? Like -1 power n sequence was diverging, but it was not diverging to infinity. It was diverging because it had no common limit, right?
Right.
So this doesn't apply. Theorem 3 doesn't apply on this one. Because we know that there are subsequences of this which converge to 1 and -1, right? Right?
Right.
There are two subsequences which definitely are converging to finite values. The reason this sequence diverges is because they are not same. However, if the overall sequence was diverging to infinity, in that case, all the subsequence would also diverge to infinity.
Right, sir.
And if it was diverging to minus infinity, then also all the subsequence would diverge to minus infinity.
Right.
Also, converse of this is not true. Converse of theorem 3 is not true. So basically it means if the subsequence is diverging to infinity, it doesn't mean that the sequence is diverging to infinity. Right?
Right.
So for example, you can consider the sequence Fn is equal to -1 power n into n, which is basically minus n if n is odd and plus n if n is even, right?
Right.
So it has two subsequences. One is the odd subsequence and one is the even subsequence. The odd subsequence is clearly going to diverge to minus infinity, and even one is diverging to plus infinity, right?
Right.
So now you cannot say from here that the sequence diverges to minus infinity. And you cannot say from here that the sequence diverges to plus infinity. Subsequences, if they diverge to minus infinity or plus infinity, do not imply that the sequence diverges to minus infinity or plus infinity. Here, the sequence is oscillatory, like it is not having it is divergent because the limits are not the same, right?
Right. Fluctuating.
Yeah. So that is theorem 3. We will stop at this point. We'll continue tomorrow and we'll finish this section. So there's a few more things and subsequences part should be fine. You can look at the question now, whatever you sent, and try that.
Okay, sir, but the और questions कैसे कहाँ से practice कर सकते हैं? ऐसे type के questions.
There is no place that I know. You will have to do it from past year's papers only. What else will you do? I don't know of any resource for this exam. If you want, you can get some higher level college books and all, but BSc maths and MSc maths, BSc maths books should be what you can check out, but I don't know for sure.
Okay, और सर जो आपने book suggest करी थी वो Thomas
That
and
book is for some limits and some tests and all for series that you can read. It's not going to be super hard. It's easy only, but it will give you an understanding of some of those tests.
okay, but it is not
As
for
only it is not for this exam. It is only for one particular chapter.
okay.
Anyway, we will cover the theory, everything. You just need to make sure that you go through the class videos and make notes and remember all of this by the time of the exam.
ओके सर, वो तो समझ में आ गया, बट कई कई जगह जैसे थोड़ी मैनिपुलेशन है, जैसे हमने का देखा था,
So
तो वो तो प्रैक्टिस बेस्ड ही आएगी, मतलब प्रैक्टिस से ही आएगी ना। जैसे कि आपने एक और एफ ऑफ एन मतलब एक सीरीज बनाई थी लेस देन करने के लिए, प्रूव करने के
I
लिए।
don't know any source. You have to buy real analysis books otherwise from BSc.
ओके
Or you have to do past year's papers. That is the only thing that you can do.
ओके, ठीक ठीक है।
Okay, we'll continue with the subsequence part tomorrow.
ओके।